All right, in lab number 3, our job is to again figure out the percent by mass of a hydrogen peroxide solution. But the technique we're going to utilize this time is going to be doing a redox titration, in which, in this case, we have a hydrogen peroxide solution, and the first thing you need to do, and this is an Erlenmeyer flask, is you need to measure out between 0.400 grams and 0.600 grams. Make sure you accurately measure that on your analytical balance. In this case, I've got 0.586 grams of hydrogen peroxide solution. Okay, to that, we are going to add 50 milliliters of distilled water just to add more volume to the solution, and we're going to acidify it because this is a redox titration. The hydrogen peroxide solution will react with this purple solution, which is called potassium permanganate. The permanganate ion in water gives it this nice dark purple color and appearance. Okay, the molarity of the permanganate solution is known to be 0.02 molar, 0.02 molar, and that's given to you in your lab directions. So I'm going to go ahead and dump in and add the 50 milliliters of water to my hydrogen peroxide. Again, it doesn't have to be all that exact. Same thing with the acid. I just want to make sure to acidify the solution, so I'm going to add in my 5 milliliters of 6 molar sulfuric acid. And then I will go ahead and add a magnetic stir bar to that and put that on my magnetic stir bar mechanism. Okay. I'm then going to get this set up so that you can see this titration in action. Sorry about that. Okay, so I'm going to turn that mechanism on so that it begins to stir the solution. And there you can hopefully see that. Now, the piece of equipment that I'm using here, this is called a burette. So for those of you that are virtual students that have not seen this yet, a burette is a column that we add a solution of known concentration. In this case, I know the potassium permanganate is 0.02 molar. That's called the titrant. That goes into this piece of equipment called a burette. We are then going to add that potassium permanganate to the hydrogen peroxide solution, which is called the analyte. Okay? And what we want to do is we want to add the potassium permanganate until the solution, one drop of it turns it from colorless, just a faint light pink, which tells us we're just a little beyond the equivalence point, but is a good enough measurement to be able to determine the concentration of the hydrogen peroxide solution. Okay, first thing you want to do is take down a measurement of the volume, which I will do for you. And the solution and the initial volume of the solution is at 0.015 milliliters. 0.15 milliliters. With the burette, we should be able to read to 2 decimal accuracy. Okay, so now I'm going to go ahead and start the titration. Now the first one is usually a quick, what we call quick and dirty one, in that we will add the hydrogen peroxide in like 1 or 2 milliliter increments. And then once the color dissipates, we'll add again, and so that we can get within 1 to 2 milliliters of the end point. Once the solution stays pink or dark pink, we know then we've gone a little bit too far. So then we can do the subsequent trials using the same technique, but now I know that the color of the solution will change around this ballpark as long as the amount of hydrogen peroxide that I use in each of the trials is fairly close to one another. Okay? All right, so I'm going to add my first little bit of hydrogen. And you'll notice how it got nice and pink and then went away. Now, what sometimes happens in this redox titration is you have to add a milliliter or 2 right away at the beginning and drive it past. It tends to want to stay pink, but once you get it past that first 1 or 2 milliliter aliquot amount, then it tends to dissipate a lot faster. Okay, so in the lab, for those of you that do lab, if it stays pink after only a couple drops, just add more until it goes colorless. It's something that I found that happens in this titration. So now I'm adding about 1 milliliter increments, and you can see how quickly it goes away. So that tells me that my reaction is not close yet. One other thing you might be able to notice or see in the flask is there are bubbles that are appearing in the container, in the flask, and that's because the hydrogen peroxide, when it decomposes with the potassium permanganate, it produces oxygen gas. So those bubbles are the product of the hydrogen peroxide that's decomposing, I should say that's reacting with the potassium permanganate. So the bubbles is the presence of that a chemical reaction is indeed occurring, along with the color change. Now, if more pink persists, then we know we're getting closer and closer to the endpoint. I'm adding my milliliter or two at a time, and what I want to make sure to do then is always keep track of where the volume was before the next addition so that I know I got a good ballpark estimate. Now, what you'll notice sometimes in a titration is you'll get some splash up. There's some, you can see it on the video, some purple that's inside the flask. So it's okay to take a squirt bottle of distilled water and just add a little water to clean off those sides to make sure all of the potassium permanganate gets into the solution. Now I notice I'm adding smaller amounts now, and the container is really starting to get much more pink. So I know I'm getting closer to the endpoint. And there the solution now is remaining that light pink color. Now I probably, if you can see from the video, I'm probably a little bit beyond the equivalence point there, which I'm not going to tell you what that is, but I'm a little bit beyond, but I can definitely know that I'm definitely within probably a milliliter of where it should be. So as long as my next amount of hydrogen peroxide is fairly close to that amount of original mass, my value should be close to that, okay? And so I know about how much to add very quickly, and then I can start going drop by drop. So I didn't really do that in this first one here. I just kept adding the milliliter increments until I had a color change, but now I know I'm within about a milliliter of the answer. So when you show up to class next time, that's what you're going to be doing. You're going to titrate the hydrogen peroxide solution with the purple potassium permanganate until it becomes light pink. Those of you that are virtual students, I will give you the data, simulated data, that you can use then to go ahead and go through the calculations of the experiment. You just won't have the chance, obviously, to work with the equipment itself firsthand. Okay? If you have any questions, this is the final lab report for this class, for this quarter. The lab report is the final page of the lab directions. So when you go online and find the lab directions, make sure you print off the last page, fill the information out, including the data, and then do the calculations, answer the questions, and submit that for your last lab report for quarter one. Again, thanks for listening.